You follow a new system where A is given 1 point, B is given 2 points, C 3 points, and so on. In this system, any word gets a score equal to the product of all the points sitting inside it. Oh, nice. So if we have a word which is, say, BAG, B would be 2, A would be 1, A, B, C, D, E, F, G, G is 7. The score would be 14. 2 into 1 into 7. We have a 6-letter word with distinct letters whose score is 570240. Thankfully, they've broken that down. 2 power 7 into 34 into 3 power 4 into 5 into 11. The score of the first 2 letters are perfect squares, and the 4th and 6th letters are prime numbers. This word does not have any letter in common with cold or with fat. The 3rd letter is the one with the highest number of points, and the 6th one with the least number of points. Find the score of the word formed by extracting the 4th and 5th letters of this word. Interesting, but I'm already taken in by this. I'm going to attack this. 6 letters, 1, 2, 3, 4, 5, 6. First 2 are perfect squares. So some A square, some B square. I'm not saying A and B, some numbers. They're all different. Right? The 4th and 6th letters are prime numbers. Prime 1, prime 2. Nice. This word does not have any letter in common with the word cold or with fat. Right? Super. 3rd letter is the highest number. Is the highest. And the 6th one was the least. Lovely. What is the score? Maybe you can find this number. It has nothing in common with cold or with fat. Very nice, very nice. 2 power 7, 3 power 4. I'm going to talk about the perfect squares. We can have each digit going from 1 to 26. And the perfect square could be 1 or 4 or 9, 16, 25. It cannot even be 36. That's not possible. And so 1, 4, 9, 16, 25. These are the possibilities. And so it could be 1. 1 can feature anywhere. It could be 4 because 2 power 7 is there. It could be 9. It could be 16. It cannot be 25 because there's only 1 5 in the product. So A square, B square is one of these. P1 and P2 could be 2, 3, 5 or 11. So the only primes sitting in this number 2, 3, 5, 11. One of these. Or P1 is one of these, P2 is the other. One more of these. Lovely. Now let's attack this cold and fat. What are the numbers that are not there? And so, not there in this system. Cold. C is 3. D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. This is 26, 25. C is not there. So there is no 3 in this system. O. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. O is not there. So there's no 15 in this system. L is not there. There's no 12 in this system. D is not there. There's no 4 in this system. No 4, that is very useful. This cannot be there. No 3, that is very useful. This cannot be there. Beautiful. So R with fat. Fat F is 6. There is no 6 in this system. A is 1. No 1 in the system. Lovely. So our A square and B square are 9 and 16. Either 9 and 16 or 16 and 9. They've accounted for. Brilliant. The 2 squares we've got. That makes life super easy. I'm going to use that after we thoroughly eliminate T also. T is 15, 16, 17, 18, 19, 20. No 20 in this system. That doesn't help us anywhere. Grab a 5. Now, brilliant. A square and B square are 9 and 16 that we've got in the bag in some form. So a 3 square gets taken care of here, and a 4 square or a 2 power 4. Remember, it could be 3 square and 2 power 4 or 2 power 4 and 3 square. That's already gone with just these two letters. Right? 3 is not the prime. 2, 5, 11 of these two primes have to be there. Either 2 and 5 or 5 and 11 or 2 and 11. One of these combinations. 3, 15, 12, 4, 6, 20 are all not there. Look at this. 3 is not there. We need to have 3 power 4 sitting in the system. 3 is not there. 6 is not there. 9 is already there. 12 is not there. 15 is not there. So we look at multiples of 3. 3, 6, 12, 15 are not there. So if you look at multiples of 3, we could have only 3, 6, 9, 12, 15, 18, 21, 24. 3 is not there. 6 is not there. 12 is not there. 15 is not there. 9 is already there. We need to have 3 power 4 in the system. We need to have 2 more 3s coming in from somewhere. So we could have this or this and this. Both of these have to be there. 21 cannot be there because there's no 7 in the number. If only 24 is there, that's only 1 3. We need 2 more 3s. 3 squares have been accommodated for, but we need 2 more 3s because 3 power 4 is sitting in the number. Or 24 cannot be there. 18 has to be there. Brilliant. Now I know 9, 16 and 18 are sitting inside. And then I'm going to recap this whole thing. Right? So we have 1, 2, 3, 4, 5, 6. 9 and 16 or 16 and 9. Okay. And then one of these numbers, digits is 18. Prime 1 and prime 2 are 4th and 16. P1 and P2 are 4th and 6th. These have to come from 2, 5, 11. One number is 18. That's already there. So we've accounted for 2 power 4 into 3 square into 2 into 3 square. This is 18. These many have been accounted for. 2 power 4 into 3 square into 2 into 3 square. So 3 power 4 has been taken care of. 2 power 5 has been taken care of. And this many have been accounted for already. Our product is 2 power 7 into 3 power 4 into 5 power 1 into 11. Brilliant. 2 power 4, 5 into 3 power 4 is already accounted for. So what is remaining is 2 square into 5 into 11. The remaining has to be in 3 letters. P1, P2 and one more because 18 is the other letter that's sitting there. Right? Now, we cannot have, the primes could be 2 and 5, 5 and 11, 2 and 11. If 2 and 5 are the primes, if the third number will have to be 22. Right? So, the prime numbers could be 2 and 5, in which case the third number is 22. Or the primes could be 5 and 11, okay, the third number will have to be 4. Or the primes could be 2 and 11, because the third one has to be 10. 2 and 11 are primes, 2 and 5 are primes, the remaining is 22. 5 and 11 are primes, the remaining is 4. Of this, we know that 4 is not there, D is not there. This is ruled out. Or definitely one of the primes is 2. 2 is definitely sitting inside. And 2 is the smallest number. This is 2. Brilliant. So 2, 5, 22 or 2, 11, 10. So I'm going to write this all over again. Just to recap. 9, 16, P1, P2. This P2 has got to be 2. Right? So we have an 18 sitting somewhere. And one more prime here. This could be 11. That means the remaining number is 10 and 18. Okay. The third letter is the one with the highest number of points. The sixth one is the lowest number of points. This is 2. Third letter is here. The score of the first two letters are perfect squares. Fourth and sixth are prime numbers. Fourth and sixth are prime numbers. So this is 2. This could be 11, in which case this could be 18 and 10. We could have 18, 11, 10. Or we could have, this is 2, this is 5, this is 22, this is 18. That is another possibility. This one is 2, this is 5, 22 is the other one. That has to be the highest. The third one has to be the highest. Third letter is one of the highest number of points. That is 22. 18 sits here. One of these two is the answer. 16, 9 in some order. 18, 11, 10, 2. 16, 9 in some order. 22, 5, 18, 2. One of these two is the answer. Is there any way of eliminating one of this? Is one of these right and the other one is wrong? Is there some way to say only one of these is possible? Fourth and sixth are primes. That condition is satisfied. Does not have anything in common with cold or with fat. 18 is not common. 22 is not common. 11 and 10 are not common. J and K, E. Lovely. This is all working out really well. Third letter is one of the highest number of points. Yes. The third letter could be 22, but this could be 18, or 18 and this could be 10. What is this? Find the score of the word form by extracting the fourth and fifth letters of this word. Tricky. So now I'm going to go to the letters. Right? So what is 2? This is B. And I'm going to write this down. I'm going to go back to this. There's a 9 and there's a 16. 9 is I. 16 is P. There's definitely an 18. 18 is R. There's definitely a 2. 2 is B. And then the last two could be 11 and 10, which is J and K. Or 22 and 5, which is B and E. Fine. IP, RB, JK or IP, RB, VE. Those are our combinations. And so, one second, I'm just having a look. You guys are discussing something else. So IP, RB, VE or IP, RB, JK. And there's something sitting in here. The first two letters are I and P, 9 and 16. Either IP or PI, one of these two. So this is IP or PI. The last one is B. Right? So IP, B, JKR. JKR, this could be K. This is the highest that should be there. RKJ. Or I'm going to rewrite this. 1, 2, 3, 4, 5, 6. This is B for sure. This is I/P or P/I. Right? Apart from this, the one other letter that we know is R. Okay? The final two could be JK or VE. Okay? IP --B or PI --B. Somewhere an R is sitting inside. We could have VE or JK. What is the word we are looking for? We're looking for PI, VE, RB. 16, 9, 22, 5, 18, 2. These two digits are prime. This is the highest. These two are perfect squares. Product is 570240. The word is PiVerb. And so PI, VE, RB. What is the product of the fourth and fifth letters here? These two, E and R, 5 and 18. That should be 90.